Graphing absolute value equations, part 1. In this video, we're going to graph the basic absolute value equation y equals the absolute value of x. Then we're going to see what happens when a multiplier is applied. So we're going to graph an absolute value equation of the form y equals a times the absolute value of x. And we're going to see what happens when you add a constant to the end, y equals the absolute value of x plus b. The graph of y equals the absolute value of x is really made of two lines. When x is greater than or equal to 0, the graph is the same as y equals x because the absolute value of a positive number is still positive. That's the line that goes through 0, 0, 1, 1, 2, 2, and so forth. And it looks just like that. But when x is less than 0, the graph is the same as y equals the opposite of x because the opposite of a negative number is positive, and absolute value turns the number to positive. So that line goes in the other direction. Y equals negative x comes down like that. So the graph of the absolute value is this V. Now that we know the basic shape of the graph, we're going to explore what happens when we multiply by a constant. If y equals twice the absolute value of x, then when x is positive, or non-negative, this is the same as the line y equal 2x. And so that means it has a slope of 2. And x increases by 1, y increases by 2. And so the line y equal 2x is steeper than the line y equal x. On the other side, when x is less than 0, the absolute value is the opposite of the number inside, so this is the graph of y equals negative 2x, which has a slope of negative 2. So the multiplier 2 outside the absolute value that we started with here gives us the two branches of the v, and the v is more narrow. You can see, for example, that if y equals 3 times the absolute value of x, then when x is greater than 0, y is going to equal 3x, and when x is less than 0, y is going to equal negative 3x, and we'll have an even steeper line on each side. So the multiplier affects the steepness of the graph. It's just the slope like it was in a line, and the v gets narrower and narrower as the number increases. If I compare the graph of y equal 1/2 the absolute value of x to the original graph y equals the absolute value of x, I have a graph that has the slope of 1/2 and the slope of negative 1/2. It's a wider v. So when I need a wider v, I would multiply by a fraction, and when I need a narrower v, I would multiply by a whole number. The bigger, the tighter the v. How about if my multiplier is a negative? For example, let's graph y equals negative the absolute value of x. So for x greater than or equal to 0, the graph is y equal negative x. And that, when x is less than 0, the absolute value of x is equal to the opposite of x. So I have y equal negative of negative x, which is the same as y equal positive x. That graph looks like this line of the v. And so the v has flipped over when I have a negative in front of the absolute value. It now faces down instead of up. If I were to graph y equals negative 2 times the absolute value of x, I get a line with the slope negative 2, when x is greater than or equal to 0, and when x is less than or equal to 0, I get a line with a slope of 2. And so I have that narrower v, just like when I multiplied by positive 2, but it faces down. The effect of adding a constant outside the absolute value is what we would expect. It's just like adding a constant to a line, because when x is greater than or equal to 0, this is the line y equal x plus 1. So it's the same as the line y equal x. It has the same slope, but it's moved up 1 and it goes through the y-axis at 0, 1. When x is less than 0, it's the same as the line y equal negative x plus 1, and that line has slope negative 1, but it goes through the point 0, 1. So what happened to my v is that it was moved up 1 because I added 1. If I say subtract 2, y equals the absolute value of x minus 2, I can just know that it is the same v but moved down 2. This idea of shifting the graph and contracting it for the multiplier and so forth can be really powerful in that I don't really have to plot any points. I just know what happens to the graph because on the right it's the same as x minus 2 and on the left it's the same as negative x minus 2. Let's put that together in an example. Suppose we want to graph y equals negative 2 times the absolute value of x plus 3. Well, the plus 3 tells me that the vertex, the point of the v, is going to be at 3. And negative 2 tells me that the slope is going to be negative 2 on the right. That means I go down 2 over 1, and it's going to be positive 2 on the left, so the other side of the v. And I've graphed that equation just by understanding what the constants do to the basic graph. To graph y equal 1/2 the absolute value of x minus 2, I look at the constant, negative 2. That's going to be where the vertex of the graph is. The multiplier is positive, so it's going to be a v facing up, and the slope is 1/2 on the right and negative 1/2 on the left. So I have a wide v whose vertex point is at negative 2. So what we've learned here is that the graph of an absolute value equation is affected by the multiplier a. If a is positive, the graph is a v facing up, and if a is negative, the graph is a v facing down. The vertex of the graph is at the point where we have this constant, so this vertex is 0b in either case. And the right-hand branch has slope a. It's neat to see how the constants affect the basic graph, and it's really useful to graph quickly.